My talk is a tale of two people. It's simpler than the one that Bob just gave. The two people are Ken Green and Rena Chasman, and synchrotron light sources. Notice I've said synchrotron light sources rather than synchrotron light source, because there are many around the world that have made use of their work. I will start with Ken Green, who was born in 1911 in Illinois, and he studied at the University of Illinois and got a PhD for the design and construction of a cyclotron to produce 1 MeV deuterons. He then was awarded a National Research Council fellowship, which supported him for further study at E.O. Lawrence's laboratory in Berkeley. During World War II, he joined the Army Signal Corps. He was an expert in electronics. But when he learned of the founding of BNL, he joined the fledgling laboratory in July 1947. So he was one of the first people to come here. He soon became deputy to M.S. Livingston, working on the Cosmotron. And he later worked on construction of the alternating gradient synchrotron, following the ideas of Courant, Snyder, and Livingston. He was at the controls when it achieved in 1960 its 30 billion volt design target. Now, I'll next turn to Rena Chasman and her route to accelerator physics at Brookhaven, and I'll return to Ken when their paths cross. Renate Wiener was born in Berlin in 1932 into a Jewish family. They moved, for obvious reasons, to the Netherlands, intending to go on to Australia, but as war came near, they escaped to Sweden instead, and Rena spent her early school years there. After the war in 1950, she went to Israel, attending the Hebrew University in Jerusalem, and ultimately attaining a PhD in nuclear physics in 1959. While her thesis was in experimental physics, she also excelled in the theoretical analysis of the results. She was invited to Columbia as a research associate in the laboratory of Professor Chen-Sheng Wu, who's known to many of us here, and who had a close relationship with Brookhaven over the years. Here she met and married a fellow postdoc, cellist Chasman. In 1961, they went with a young child to Yale, where Professor Bromley arranged for her to have, at her request, a part-time appointment. So she had some good mentors during this time who were taking care of her. They then moved on to BNL, where an expected appointment for her fell through. She briefly took a job at the Sigma Center, compiling data on neutron cross-sections. But there was a need for more expertise in accelerator physics at this time, and together with the knowledge of her strengths as a physicist, this led to a position in the accelerator department, where she quickly learned much of the science and the several projects that were underway then at Brookhaven. Among those projects were a new linear accelerator injector for the alternating gradient synchrotron and the Isabel proton storage rings. And here she joined forces with Ken Green on these designs. Her contributions were sufficiently impressive and important that she was proposed for a 10-year appointment, and that was granted. This was in 1971. In 1970, though, a group of physicists and the then chair of the accelerator department made a proposal for a new source of X-rays at Brookhaven based on radiation from an electron storage ring. Rena and Ken developed a design subsequently named the Chasman-Green lattice that was a great improvement over others that were based on accelerators used for high-energy physics. Rena and Ken recognized this, and the result was a proposal for what became the NSLS. This is a schematic of the Chasman Green double bend achromat. I don't want to go into the technicalities of this, but the important point was that they had to have a set of magnets that kept everything in perspective on this. And the proposal was very important and was used everywhere. It was called a lattice because it was a periodic structure that would be repeated around the rings. And the X-ray ring had 8 cells. The VUV ring had 4 cells with these various magnets in them. It was novel and extremely useful. Unfortunately, in the summer and autumn of 1977, all of this came to a tragic end. Ken went on vacation to visit his son in Texas and died suddenly. Rena, meanwhile, had been diagnosed with cancer in 1972, and she had carried out much of her work while undergoing difficult chemotherapy. One would not have noticed this since the quality and quantity of her scientific output continued at a prodigious pace. Here is the announcement in the Brookhaven Bulletin that Ken Green had died at age 65. There was a tribute for him by Leland Hayworth, which is very nice, and which takes into account all of his contributions, not just the ones to the light source that I'm talking about now. Unfortunately, 2 months later, and this was announced in the Brookhaven Bulletin, Rena Chasman died at age 45. She was admired by everyone who came in contact with her for her personal warmth and intelligence. Among her many qualities were her linguistic skills. She spoke fluent German, Swedish, Hebrew, French, and English. The latter was unaccented, unusual at BNL, where there were a number of staff members who had been brought up in Brooklyn and the Bronx. Her loss was an enormous one, of course, for her family, for Brookhaven, for the NSLS, and for the world scientific community. Brookhaven Women in Science established an award in her memory for a woman returning after an interruption to study or work in science. The development of a design expressly for a synchrotron radiation source with a laboratory staff that could make varied use of it and with colleagues in many universities and industrial laboratories showed the advantage of a multidisciplinary laboratory like Brookhaven. Now, the work that they did has received praise throughout the world. The European Synchrotron Radiation Facility had an issue in March of 1996, nearly 20 years after Rena had died, to praise them. And as they say, the Chasman Green lattice was invented by 2 Brookhaven machine physicists for the NSLS. An expanded version of this lattice has been adopted by the ESRF program. Besides its basic features, the laboratory offers an impressive high potential of flexibility, of tunability and flexibility. And then this very nice statement and generous statement, this report pays homage to its inventors. Now, their work has been utilized throughout the world. Here are some synchrotron radiation sources using the Chasman Green lattice. The NSLS, European Synchrotron Radiation Facility, the Advanced Photon Source at Argonne, Spring 8, this stands for Super Photon Ring, HEEV in Japan, Diamond in the UK, something comparable to NSLS-2, Soleil in France, and the Canadian Light Source. In addition, there are many other synchrotron radiation sources that make use of variants of the Chasman Green lattice. The Advanced Light Source at Berkeley is an instance of this. But we don't account it here because these use precisely the structure that Ken and Rena had visualized. Now, I've repeated this to show it because I want to show the next slide. You'll notice two bend magnets over here. And here is the Chasman green cell. Here and here are the two bending magnets that you saw in the preceding one. And this is repeated 30 times around the ring, as opposed to the 8 for NSLS1 and 6 and 4, I'm sorry, for the UV ring in NSLS1. Now, there is also in NSLS1, the Green Chasman Library, which in fact is a memorial to them. When the light source, NSLS1, is shut down and NSLS2 comes along, this will be missing. And I hope that there will be a suitable memorial for Ken and Rena that can be provided after NSLS1 is retired and NSLS2 is operating with utilization of the Chasman green lattice. That is what I wanted to say about them. It is a tale of two people, and with very different backgrounds, but with a common purpose and a very fine legacy. Thank you.